All right, today we're talking about assignment 8.6, probability. This first section says determine whether the scenario involves independent or dependent events. Then find the probability. Express probabilities as simplified fractions and as decimals rounded to the nearest hundredth. So notice this first question says you flip a coin and then roll a fair six-sided die. The coin lands heads up and the die shows a 2. First, we need to decide, are these independent or dependent events? Now, the difference is if it's independent, then what happens with the first thing will have no impact whatsoever on what happens with the second thing. If it's dependent, then what I get the first time will change the probability of the second event. So here, I'm flipping a coin and rolling a die. Well, whether that coin lands heads or tails is not going to have any impact whatsoever on what I get when I roll my die, which means that these are independent events. They have no impact on one another. Now, to find the probability, remember that probability is equal to the number of outcomes we want divided by the total number of possible outcomes. So, for example, here on problem 1, when we flip the coin, well, there are 2 possible outcomes when I flip a coin. I could get heads or I could get tails. In this case, I want my coin to land heads up. So I have a 1 out of 2 chance that my coin will land on heads. For my second possibility here, now I'm rolling a 6-sided die. Well, if I'm rolling a 6-sided die, that means that there are 6 possible outcomes. 1, 2, 3, 4, 5, or 6. And I want my die to show a 2. Since there's only 1 2 on a die, I have a 1 in 6 chance of rolling a 2. Then, to find the probability of both of these things happening, I'm going to multiply the probability of each individual event. 1/2 times 1/6. Well, if I multiply this straight across, 1 times 1 is 1, and 2 times 6 is 12. So I have a 1 in 12 chance of flipping a coin and getting heads, and rolling my die and getting a 2. But remember, we want our answer written as both a fraction and a decimal. So I know that the fraction is 1/12. To get the decimal, I'm going to just type 1 divided by 12 into my calculator, and I get 0.08 if I round to the nearest hundredth. So I'm going to say this probability is either 1/12 or 0.08. And there's my probability written as both a fraction and a decimal. Well, here on problem 2, a cooler contains 11 bottles of a sports drink, 6 lemon lime, and 5 orange flavors. You randomly grab a bottle to give to your friend, then you randomly grab a bottle for yourself. You and your friend both get lemon lime. Well, first I need to decide, is this an independent or dependent event? Well, there's 11 bottles in the cooler, but when I reach in and pull one of the bottles out, that's going to change the probability depending on which bottle I chose. It also changes the number of possible outcomes. Instead of 11 possible bottles, there will only be 10 the second time I reach in. So this is a dependent event. What I get on the second event depends on what I got the first time. So in this case, I notice that I have 6 lemon lime flavored and 5 orange flavored sodas. When I reach in and grab my drink, I want the first one to be lemon lime and the second one to also be lemon lime. So the first time I reach into my cooler, I have 11 possible outcomes. There are 11 bottles I might grab. And of those 11 bottles, 6 of them are lemon lime. So I have a 6 in 11 chance of getting a lemon lime the first time I reach into the cooler. Well, the second time I reach into the cooler, there aren't 11 bottles there anymore. Now there are only 10 bottles in my cooler. And assuming that we both get a lemon lime, instead of having 6 lemon limes in the cooler, now there are only 5 lemon limes. So my probability here is 6/11 times 5/10. Well, if I go ahead and multiply this out, I have 6 times 5, which is 30, over 11 times 10, which is 110. If I simplify that fraction down, I get 3/11. So there's a 3 in 11 chance that I'll reach into the cooler 2 times in a row and get lemon lime both times. I also would like to write this answer as a decimal, so I'm going to type into my calculator 3 divided by 11, and my calculator says it's 0.27 if I round to the nearest hundredth. So I have a 3 in 11 chance, or a 0.27 chance, of reaching into this cooler twice and getting a lemon lime both times. You can go ahead and finish 3 and 4, but go ahead and look at this next section. The table below shows the marital status of the adult U.S. population in 2010. Numbers in the table are expressed in millions. Use the data in the table to solve problems 5 through 9. Express probabilities both as simplified fractions and as decimals rounded to the nearest hundredth. So here's our table, and we want to know if one person is randomly selected from the population described in the table. Find the probability expressed as both a simplified fraction and as a decimal rounded to the nearest hundredth that the person is divorced. So if I want to know the probability that just any random person from this population is divorced, first I need to take note of the total number of divorced people, which in this case is 24, out of the total number of people that we surveyed, which was 242. Now I'm going to simplify this fraction down. So I have 24 over 242, and I know that I can divide both of those by, let's try 4. So I know that 24 divided by 4 is 6. 242 divided by 4 is 60.5. I don't really want the decimal, so instead of dividing by 4, let's try just using 2's. So if I divide them both by 2, 24 divided by 2 is 12, and 242 divided by 2 is 121. Now I know that I can't simplify that any further, so my fraction is 12 over 121, and to get the decimal, I'll type in 12 divided by 121, and my calculator says it is 0.99, but if I round that to the nearest hundredth, it's actually going to be equal to 0.10. So I know that 12 out of 121 people in this survey were divorced. Now that you've seen that, go ahead and try the rest of this assignment.